So this video is for integrated 2. This is the Tireless Trig worksheet from chapter 4 of our math analysis. So on this first section, what you guys are going to do is you're going to find the exact value on the unit circle for each of these. So when we're doing this, you want to pay attention to the direction that we're going to be going. So in this case, this is a negative angle that I'm trying to find the cosine of a negative pi third. So I'm going to be going this direction. Okay. So negative pi thirds is going to be right here. And I want the coordinates of that point. And so if we're moving, we're going short, comma, long. So when I think short, I'm thinking 1/2. And when I think long, I'm thinking root 3/2. And it's a negative because of the quadrant I'm in. And then the cosine is going to be your x coordinate. And so this answer is 1/2. On B, we're going to be going the positive direction. So we're going to be going to 4 pi thirds. And 4 pi thirds is going to be all the way over here. And the coordinates of this, again, it's going to be short, comma, long. We're in quadrant 3, so it's going to be a negative 1/2 and a negative root 3/2. I want the tangent, and tangent is your y coordinate over your x coordinate. So we're going to have a negative root 3/2 divided by a negative 1/2. Now, when I'm dividing by a fraction, I can really multiply by the reciprocal. So I can think of it as multiplying by a negative 2/1. And when I do that, I'm going to end up with a positive root 3. On C, 11 pi 6 is going to be right here. And I'm going long, comma, short. So this is going to be a positive root 3/2, comma, negative 1/2. Sine is your y coordinate, so our answer is a negative 1/2. On D, 3 pi 4 is going to be right here. And that is going to be a root 2/2, negative root 2/2, comma, positive root 2/2. And when I do y over x, I'm going to have a root 2/2 over a negative root 2/2. And that is just a negative 1. So my answer is negative 1. On number 2, for these ones, I'm going to try to find the 2 angles that would give us the answer for this. So I want to know where my cosine is negative. And my cosine is negative in quadrants 2 and 3. They want us to do this in degrees. So I'm going to be trying to figure out where my cosine is a negative 1/2. That's my x coordinate. That's going to be here and here. And in terms of degrees, that's going to be 120 degrees. And down here, this is going to be 240 degrees. On B, I want my sine to be positive, and my sine is positive in quadrants 1 and 2. And this time I want my answer in radians, and I want where my sine is a 1/2, and my sine is a 1/2 in both these spots. And so this is going to be a pi 6 and a 5 pi 6. On C, tangent root 3. So my tangent is going to be positive in quadrant 1 and quadrant 3. And then when I'm dealing with this, I'm figuring that this is going to be either pi 6 or pi thirds. I'm thinking I probably want my root 3/2 in my numerator and my 1/2 in my denominator, because if I divide by that fraction, I'm going to multiply by the reciprocal. And you see, when I do that, I am going to end up with a root 3. So remember, tangent is y over x. So I want my y to be a root 3 halves, and then my x is going to be the 1/2. So that is going to be here and here. So these are pi thirds and 4 pi thirds. And those are going to be our two angles. On D, remember cosecant's the reciprocal of sine because C doesn't go with C and S doesn't go with S. So sine of that same angle, I'm going to take this and I'm going to write it as a reciprocal. So I really want to know where my sine's a negative 1/2. And my sine is negative in quadrants 3 and 4. So this is where I'm going to be. And I want my sine to be a negative 1/2. So I'm going to be in these two spots. So that is going to be 7 pi 6 and 11 pi 6. On E, my cosine positive is going to be in quadrants 1 and 4. And I want this in degrees. And my cosine being a root 3 halves, that is going to be here and here. And so this is going to be 30 degrees and 330 degrees. On F, I want a positive sign. So a positive sign is going to be in quadrants 1 and 2. And my sine being a root 2 over 2 is going to be here and here. And in radians, this is going to be pi fourths and 3 pi fourths. So I want to find the exact value of the cosecant of 120 degrees. Now 120 degrees is actually on the unit circle. I'm going to just sketch one here. So this is going to be in quadrant 2, and that is going to be this spot right here. And so the coordinates of that is going to be a negative 1/2, comma, root 3 halves. Now cosecant is going to have the reciprocal of sine. So I'm going to basically find the reciprocal of sine. So sine of 120 degrees is going to be my root 3 over 2. So that means the cosecant is going to be the reciprocal of that, which is going to be 2 over root 3. And we rationalize, we multiply the top and bottom by root 3. And we get 2 root 3 over 3 as our answer. On 4, we're going to put this into our calculator. And so let me get my calculator here. And so I want my calculator in degrees. So I'm going to change this to degree. And then I'm going to do sine. And if I want to type in the actual degree minute seconds, I'm going to go 27. I'm going to hit the second and apps button. There's my degree. 4 minutes. I'm going to hit the second and apps button again. And there's my minutes. And then 5 seconds. And I have to hit the alpha and the plus. And then I'm going to get 0.4550. Now, if I didn't have that button, I can do it this way. Just write it as a degree. 27 plus 4 minutes is 4 out of 60. That's how many degrees we have. Plus 5 seconds is 5 out of 3,600. Again, that's how many degrees we have. And you see I get the same answer. So my answer again is 0.4550. On number 5, we want to put this into our calculator. So remember, S doesn't go with S and C doesn't go with C. So I'm really going to go 1 over the cosine of 92.22 degrees. So 1 over cosine of 92.22 degrees. I end up with a negative 25.82. That is my answer. Now on 6, this is meant to be a degree symbol. They got cut off, so we want to find the reference angle for 145 degrees. So 145 degrees, if I'm drawing 145 degrees as an angle, I'm going to be starting here and going into this quadrant. And so going from here to here, I went a negative 145 degrees. And really, I want to know, okay, what's the rest of it to here? Okay, I want to know to here, what's the rest of it? So I am going to be taking 180 degrees, which I didn't quite make, minusing 145 degrees. And I am going to get 35 degrees. And that is our reference angle. So this right here is going to be 35 degrees. On 7, I'm going to do the same idea, but I'm in radians. So I'm going to start here, and I'm going to 9 pi 13ths, which is going to be less than pi. So from here to here, we went 9 pi 13ths. I want to figure out what the rest of this is going to be. And so the rest of this is going to be the remainder of pi. So I'm going to go pi minus 9 pi 13ths. And that's going to give me 4 pi 13ths. And that's my answer. On 8, this is in radians. This is negative. So if I'm drawing this out, I'm starting here. I'm going negative 2.8, which is going to be in this quadrant. So we're going this way, which is a negative 2.8 radians. And again, I want to figure out the rest of this to here. So going to there would be pi. So I'm going to go pi minus 2.8 to see how far off I was. So pi minus 2.8 is 0.34. So this is going to be 0.34 radians, and that's going to be my reference angle. On number 9, the terminal side of the angle in standard position passes through the point negative 7, 24. So if I'm thinking about this, I'm going to be drawing a triangle. I'm going to be in quadrant 2 because I have a negative x and positive y. So let's say that this is my angle. I know that this is negative 7 and this is 24. So I am going to do Pythagorean to figure out the hypotenuse. So I'm going to go negative 7 squared, which is 49, plus 24 squared. And I know it's 625. And the square root of 625 is 25. So I am going to have, for the cosine of my angle, adjacent, which is negative 7, over hypotenuse, which is 25. On 10, I want to find the two angles in radians. That is going to give me a sine of negative 0.7568. So if I'm talking about sine being negative, I'm going to be down in these two quadrants. And if I'm thinking about it as a negative 0.78, hold on, I need to draw. I'm going to be trying to figure out where I am in both those quadrants 3 and 4. And so what I'm going to do, instead of finding the sine of the negative angle, I'm going to find the reference angle. So my theta is going to be equal to sine inverse. And again, I'm going to use the positive number. So I find my reference angle, 2568. So I'm going to put that into my calculator. And when I do, I'm going to do making sure my calculator is in degrees. Actually, in this case, radians. So then I'm going to do sine inverse of, and I'm going to do it as a positive 0.7568. And so over here, I would be in this area, let's say 0.86 radians. So I don't want it there. I want it down here and I want it over here. So I'm basically going to take pi and add 0.86. So pi and add 0.86 and I get about a 4. And over here, I am going to be taking 2 pi minus 0.86. And so when I go 2 pi minus 0.86, I end up with 5.42 radians. On number 11, we're going to be in quadrant 3, because we know cosine is negative in quadrants 3 and 2, and they're telling us it's in 3. So if I draw my right triangle, I know the angle here has a cosine of a -2/5, so that's going to be adjacent. So that's going to be a -2. That's where my negative goes. And my hypotenuse is going to be 5. And I'm going to basically go 25 minus 4, which is 21. And so this is going to be the square root of 21. And so when they ask me for sine is going to equal a root 21 over 5. On number 12, we want to find the exact value for the sine, cosine, and tangent. So I'm going to find this side here. I'm just going to call it x. And when I call this x, what I'm going to be doing is using Pythagorean. So my hypotenuse is 61, so 61 squared minus 11 squared. And that is going to give me 3,600. And then I'm going to raise it to a 0.5, which is the same as square root. And so this is a 60. And so now when I'm dealing with sine is going to be equal to opposite, which is 11, over hypotenuse, which is 61. Cosine is going to equal adjacent, which is 60, over hypotenuse, which is 61. Tangent is going to be opposite over adjacent, so 11 over 60. On 13, we want to figure out what quadrant is going to satisfy both of these. So I want my tangent to be positive, which is going to be in quadrant 1 and quadrant 3. I want my cosine to be positive. So my cosine is positive in these two quadrants. And as I'm shading here, the one that has both colors is my answer, which is quadrant 1. That is our answer. On 14, okay, we're going to be making a right triangle. They want it to be an acute angle, which means that it's going to be in quadrant 1. So I'm just going to draw a right triangle here. And this angle theta, if the sine is 5/13, this is a 5, this is a 13. We need to find the leg. So I would go 13 squared, which is 169, minus 5 squared, which is 25, and we get 144. And the square root of 144 is 12. So this is going to be a 12. So now when they're asking us to find the cosine of this angle, the cosine of this angle is going to be opposite, which is, adjacent, which is 12 over hypotenuse, which is 13. Okay, number 15. So on number 15, they want us to figure out what the cosecant is if we know that the cotangent is 5/12. Now, they're talking about trigonometric identities. We're going to talk about those later in this chapter. So we're going to just do it using our right triangle. They told us that this is an acute angle. So again, we're going to be in quadrant 1. So I'm just going to draw a triangle. And this is my angle. And my cotangent is, well, tangent is opposite over adjacent. So cotangent is adjacent over opposite. And then we're going to see that we're going to get a 5, 12, 13 right triangle again. So then they want us to find the cosecant. Okay, now remember, to find the cosecant, it probably helps to find our secant, because that's the, secant, our sine, because that's the reciprocal. And sine is going to be opposite, which is 12, over hypotenuse, which is 13. So then we're going to have the reciprocal, which is going to be 13 over 12. And that's going to be our answer. On B, we want to evaluate each of these without a calculator. And this is 120 degrees. So for this, I'm going to just draw a unit circle that I'm going to use for each of these. Okay. For the first one, 120 degrees is going to be in quadrant 2. So if I'm looking at that, my 120 degrees is going to be here. And the coordinates is going to be a -1/2, comma, √3/2. So the cosine is going to be a -1/2. So the next one, we want cosine of 3π/2. 3π/2 is going to be down here. And that is going to be 0, -1. And my cosine is my x, so that's going to be 0. And when I'm talking about 2π/3, that is going to be in quadrant 2. And it's going to be the same as the 120 degrees. But this time I want tangent. And so tangent is going to be y over x. So I'm going to have my √3/2 over a -1/2, which is the same as me multiplying by the reciprocal. Okay. And so I am going to end up with a negative root 3. On 17, okay, we have a situation here where we have a tailgate of a truck that's 3 feet above the ground. And there's a ramp that we're loading the truck up with. We want to figure out the length of that. We know it's a 25-degree angle. And we want to, again, find the length. So I want to find this. I'll just call it H for hypotenuse, but that's what I want to find. So I am going to use tangent. And so I'm going to be doing tangent of 25 degrees. Let me move this out a little bit. Is equal to H over 3. So I am going to have 3 tangent of 25 degrees equals H. And tangent, I'm not using tangent, sorry. I'm using sine. Sine of 25 degrees. So this would be 3 sine of 25 degrees. I apologize because it's got opposite and hypotenuse. So I'm going to go 3 sine. And I notice I've got it in radians, so I need it in degrees. Okay. So 3 sine of 25 degrees. I end up with 1.27. Let's see. Opposite over hypotenuse. Just double checking my math here. Oh, it helps if I set up my fraction correct. Yes. Okay, so it is, and I keep saying opposite over hypotenuse, but I'm not doing opposite over hypotenuse. So sine of 25 degrees is going to equal opposite, which is 3, over hypotenuse, which is H. So then when I rewrite this, this is going to be H is equal to 3 divided by sine of 25 degrees. Sorry about that. I'll get it right eventually. So 3 divided by sine of 25 degrees ends up giving me a 7.1. And this was in feet. So this is going to be 7.1 feet. That's going to be our answer. On 18, okay, we want to use trig identities to get the left-hand side to be the same as the right-hand side. So for the left-hand side, I'm going to rewrite cosecant and tangent in terms of like sines and cosines. So cosecant is 1 over sine of theta. That's going to multiply with my tangent, which is sine of theta over cosine theta. And we're trying to get this to equal a secant of theta. Okay, we're not doing anything to that side. We're trying to make the purple side look like the blue side. So on the purple side, this sine of theta and this sine of theta are going to make a 1. And I'm going to be left with 1 over cosine theta. And then on this side, I've got secant theta. Now, the reciprocal of cosine is secant. So this is going to end up being a secant theta equal secant theta. So we got it. 19. So to find the height of a pole, a surveyor moves 100 feet away from the base of a pole, and then from an eyeball level height of 5 feet, measures the angle of elevation to the top of the pole to be 35 degrees. Find the height of it. Okay. So we kind of sketch this out. So I'm going to have a person who, if they're looking straight across, is going to end up seeing a pole. Okay, so that's going to be our pole. And if they're looking up at that pole, this is at the top of it, that's going to be a 35-degree angle. We know that they are going to be 100 feet away from this. We also know that the distance from their eyes to the ground is 5 feet. So over here, this is going to be 5 feet. So we are trying to find the height of the pole. So the first thing I'm going to do is I'm going to try to find this. I'm just going to call this Y. And that is from here to here. So to do that, I am going to have opposite and adjacent. So I'm going to do tangent of 35 degrees is equal to opposite, which is my Y, okay, over adjacent, which is 100. So I'm going to have 100 tangent of 35 degrees is equal to Y. So 100 tangent of 35 degrees is 70.02. And then I am going to want to add that to the 5. And when I do, I'm going to get 75.02. That's going to be the height of the pole. For this one, we want to find where the cosecant is 4/3. Well, remember the reciprocal of cosecant is sine. And so if my cosecant is 4/3 at that angle, my sine is going to be 3/4. So that's what I'm going to find. And my sine is going to be positive in quadrants 1 and 2. So this is where I'm going to be focusing. And so what I'm going to do is I'm going to do inverse of sine. Inverse sine of 3/4. That's going to give me my answer in quadrant 1. So, and I want my calculator in degrees, which it is. So sine inverse of 3/4 gives me 48.59 degrees. So one of them is going to be 48, I apologize. 48.59 degrees. And the other one's going to be on the same on the other side. And to find it, I'm going to take 180 minus 48.59. So 180 minus 48.59 gives me a 131.41 degrees. And that's our second angle. Okay, we're converting from degrees to radians. Now, all of these ones happen to be on the unit circle as one of the nice values, except for letter D. Okay, now 2 ways to do this. If I'm thinking about the unit circle, 225 degrees is going to be in quadrant 3. It's going to be this value right here. And that is going to be 5 pi force. But you can also figure it out going 225 degrees times pi over 180 degrees, which is just a fancy one, is going to equal 225 pi over 180. And the degrees are going to cancel out the units. And so when I put in my calculator 225 over 180, I see I do get a 5/4. So my answer is 5 pi force. Okay, which I did get here from my unit circle. You can find it both ways. Okay, a negative 60 degrees. Again, this is going to be on our unit circle. a negative 60 degrees would be right here. And in terms of radians, that's going to be a negative pi thirds. That's going to be my answer. But again, I can take negative 60 degrees times it by pi over 180 degrees. My degree symbols are going to cancel out. And I'm going to get a negative 60 pi over 180, which 60 goes into 183 times. So I'm going to have a negative pi thirds, which is what I got here. C. So on C, 2 pi thirds. So again, that's on the unit circle. 2 pi thirds is going to be right here. And that is going to be 120 degrees. But again, you could also have taken 2 pi thirds and times it by, this time, 180 degrees over pi. The pi's are going to cancel out. And I am going to end up getting basically 360 degrees divided by 3, which is 120 degrees, like I have in the picture. Now, the last one, I'm going to have to do some math and use a calculator. So when I'm dealing with this in radians, this is 0 radians. This is pi halves, which is 1.57 radians. This is pi, which is 3.14. And if I take 3.14, let me put this. If I take 3.14 and I add 1.57, I get a 4.71, and then here, this is going to be a 6.28. So I am going to be over here. Let me just draw it out. So I would be starting here, and I'm going to be somewhere in here. And really, I'm going this direction. Okay, but what I want to figure out is what that is in degrees. So what we're going to do is we're going to take 5.1 radians times it by 180 degrees over pi. And I'm going to put that into my calculator. So 180 times 5.1 over pi. And I get 292.21 degrees. That is my answer. And that's the end of this video.